Welcome to Series 2. This is the extension of the Quantumology series, looking into the principles and concepts behind quantum mechanics. So let's see where the exploration goes, because we're starting off today with the uncertainty principle, or uncertainty per se, let's put it that way. The first arrival, really, of the uncertainty principle way back in the 1920s, 30s sort of borderline was when Werner Heisenberg came up with the concept to illustrate the fact that you could not measure the speed or trajectory of a particle at the same time as measuring its position. And paradoxically, concurrently, you cannot measure its position at the same time that you're measuring its speed or trajectory. So this conundrum essentially was where the uncertainty principle started its life, and it's been guarded fiercely by scientists since that time, who would insist that that's all there is to it. It's just a measurement problem. Uncertainty is simply a problem of not being able to measure two things at once. Since then we've come quite a long way, and later on in the video I'll go into some of the reasons why and the ways in which we've come a long way. But essentially this is the starting point, and the starting point for some very deep discussions, I would imagine, and some explorations into territory which may or may not be familiar to you, but at least we will be able to explore some concepts that may be outside the box somewhat. So I'm looking forward to seeing where this goes, and it's been a very interesting ride so far. So let's see where this little video takes us and what happens from there. Now, where was I? Oh yeah. Redshift. When things are moving away from you, they produce redshift. So that's the spectrum of light that hits your eyes or your telescopic gear when something is moving away from you. When it's moving towards you, you get the other end of the spectrum hitting you. You get blue shift, so you get the blue spectrum of light if something is coming towards you. You have probability waves in existence in the quantum world. These are the options of what might happen. Now, the most likely option for me as the observer of my immediate surroundings is that the things that I see on the desk in front of me are going to be there tomorrow when I come back to sit down at the desk. That's what I expect. There is a level of uncertainty, there is a wobble in the quantum matrix that says that all these things might possibly vanish into another dimension completely and not be here tomorrow. But that is unlikely. The probability is that everything will be exactly where I left it. But the probability waves, being uncertain in themselves, give rise to another feature of nature which I think is really important to bring into the equation. And I'm bringing it into the equation quite unashamedly, this other feature of nature, despite the fact that Professor Brian Cox and his friend Jeff Forshaw do not like anyone trampling on the uncertainty principle, and they don't like anybody coming in and saying that there could be any more to it than what the scientists decree there should be. Well, he actually wrote in his book, co-authored with Jeff Forshaw, that the uncertainty principle is a doorway through which all kinds of charlatans and purveyors of tripe may force their philosophical musings. Nicely put, Professor Cox. We will have a debate on that one day, hopefully, because there is a lot more to the quantum world than you know, or I know, or anybody else knows at the moment, and so uncertainty is as a fair game territory as anywhere else for exploring our philosophies and musing upon them. You know that you are a unique being. I'm a unique being. Wall, bless him, is a unique owl. There is no other tawny owl that looks exactly identical to Wall. He will have different feather markings on his face and his body to every other tawny owl that exists, just as you or I will have slightly different features to every other human that exists. Snowflakes are unique. Grains of sand are unique. There is no limit, apparently, to uniqueness. And we don't know how far down uniqueness goes in terms of the quantum mechanical package. Could it possibly be that quantum particles themselves are in some way unique? We don't know the answer to these questions. But what we do know is that, contrary to the Groundhog Day principle, every day is different. No two parcels of time can be exactly the same as any other two parcels of time. It just doesn't happen. You can walk the dog 16 billion times, but every time you go and walk the dog, that dog walk will be slightly different from the walk that you had yesterday and the day before and the day before that. They will all be slightly different from each other. It's every time you go to work, it's a different day. Slightly different. Those slight differences make up uniqueness, and that's why there is a certainty in uncertainty. The certainty is that nothing will happen the same way twice. Everything that can happen will happen. Yeah, okay, I'll give you that, Professor Cox and Mr. Forshaw. But also, it's certain that everything that can happen will not happen the same way twice. Not in this universe, anyway. There's been an addition to the scientific situation that I've uncovered recently. Now, it seems that in the scientific community, the uncertainty principle has been extended. So there is now an extended uncertainty principle. Yes, there really is. I just want to have a look at the extension of the uncertainty principle in our terms, the terms in which I'd like to refer to it here. I've recapped a little bit on the board. So the first one, this is speed. I've drawn a bird because I like drawing birds, as you know, I'm fond of them. So this is the speed, this is the position, and as you know, the classic interpretation of the uncertainty principle is that you cannot measure the speed and the position of something at the same time. Here we have the wave-particle duality aspect. So you've got the particle, which is produced by collapse of the wave packet, as we've discussed in wave-particle duality. And this particle is itself fuzzy due to the nature of its electrons and the electron's relationship with the nucleus of the atom, in particular the proton. This is the syntropy, or the two arrows of time that converge like crossing trains on a track. The present moment being the centre of that track. So you've got this direction of time, let's say that's past to future, and then this direction of time, let's say that's future to past. In the middle you've got the present moment, which also happens to encapsulate particle reality, and there are all these options shooting off in a kind of feather format. So the one that's going to be realised in either direction is the one that makes the present moment occur as it does. That every present moment is unique for some reason. It's the uniqueness aspect that I feel is down to uncertainty, and I'll explain why in a moment. So there you have these waves of probability around the structure of the present moment, or the present atomic construct as we see it here, and those waves are variable, so they're varying all the time. And this diagram down here you might remember being vaguely reminiscent of one I've done before when I was talking about quarks and neutrinos. It's oscillation. So herein you have these particles, quarks or neutrinos, changing from one thing to another, and while they're changing in gargantuan forms. They are changing their electron volt charge and their mass from tiny minuscule amounts to huge, unfathomably enormous amounts, and yet they are the same particle. So how does this happen? This is a subject that I feel is woven in there somewhere into the bedrock of the uncertainty principle, but I'm not sure where, so your thoughts would be very welcome on that. Any extension of the uncertainty principle veers us into territory that essentially may disturb positivists, because you cannot prove something that is uncertain. But what we have seen by the nature of the natural world that we see around us all the time and are free to explore is that everything is unique, and therefore there has to be a natural principle at work in ensuring that everything is unique. That hasn't yet been explored. It hasn't been attributed to any particular quantum theory or principle. However, I do believe that it belongs with uncertainty. And the reason for that is that if nature is creating a constant stream of unique entities, then that essentially means that each entity is unique by an undeterminable characteristic. So you've got a unique entity in amongst its peers of unique entities. Snowflakes, for instance, grains of sand, leaves on trees, blades of grass, etc. And the parameters within which nature determines that that object, that entity, is going to be unique could not be determined by an observer. You would not be able to be certain which set of parameters is going to appear in order to make that entity unique in the way that it is. So that's why I'd like to suggest and put forward that the uncertainty principle needs extending still further towards a super extended uncertainty principle, which encompasses the feature of uniqueness in the natural world, and explains, at least in part, how that process occurs. So I got Wal to turn around eventually, just to say goodbye to you. I'd like this little chap to say goodbye to you as well. He's a fairly new addition. This is Wordley. He's a collared dove. He's also unique. He's a little bit scruffy at the moment, but he's only been with us a little while. So when he molts out, he'll look better than that. So anyway, that's it from me. Have fun with your particle reality. Enjoy this series, because series 2 is going to include some deep principles that apply to you and yours and your workplace and your life and your environment. And who knows where your explorations may lead. You might be tempted and inspired to look more deeply at the quantum world and find therein some gems of information that you can utilise along the way. I hope you've enjoyed this little video and that it gives you some food for thought about the uncertainty principle. And I hope to see you again next time. Don't forget to look us up, follow this channel, do subscribe to it, find us on Facebook and find the websites. And I'll see you again soon. Thank you. Bye.